concepts and construct are two very, very similar. Is that right? Let's take a look. A concept is an abstraction from observed events. Right? Its purpose is to simplify thinking by including a number of events under one general heading. I'll give you an example. Say, mainstreaming is a concept, is that right? That means what? Include what? Include students who are, well, say, slow learning students, handicapped, students with learning disabilities and all that, to what make them in total inclusion, include all of them in a normal classroom. And I mentioned another concept is what? Affirmative action. Remember that? Affirmative action. And I hope you remember that, okay? So both the United States and Canada have been what? Have been working on this here, affirmative action. So it is an abstraction from observed events, all right? So we don't have to what? We don't have to go through the whole definition, right? So a construct is a higher level abstraction that is inferred, the construct now, right? That is inferred from observable behavior. Remember, construct, I mentioned that we have lots of construct, is that right? Intelligent is a construct, laziness is a construct, motivation is a construct, something we infer from observable behavior, is that right? We cannot touch it, we cannot, see it, but then we infer from observable behavior. So constructs such as motivation, problem solving ability, creativity, IQ, laziness, prettiness, all that, okay? It's simply a label we assign to something we observe. So in terms of what? Complexity, a concept is far more complex than what? Than a construct. Some definitions of concept and construct, right? So, constitutive definition. Constitutive definition is a formal definition in which a term is defined by using other terms. All right. So, for example, intelligence is the ability to think abstractly, or love is the total devotion and dedication to the well-being of the loved one. Something like this, all right? Operational definition. Operational definition is one that ascribes meaning to a concept or a construct by specifying the operations that must be performed in order to measure or manipulate it. Right? So that is one operational definition. For example, love is not worth it unless it recklessly risks everything. So here, a measured operational definition refers to the operations by which investigators may measure a concept. For example, IQ by the Stanford-Binet test. All right. So another one is An experimental operational definition refers to the steps taken by a researcher to produce certain experimental conditions. For example, frustration. What is frustration? Is preventing what? Preventing subjects from reaching a goal, right? Say cognitive dissonance. What is it? Cognitive dissonance in an experimental operational definition is that requiring the subject of a study to make what public statements contrary to their private beliefs. Right? So that the action will cause dissonance. Okay. So operational definitions are essential to research because they permit investigators to measure abstract concepts and construct and permit scientists to move from the level of constructs and a theory to the level of observation upon which science is based. Is that right? So that is what that is important. All right. Bruner's, let's take a look at Bruner's cognitive theory. So Bruner's theory of conceptualization and categorization. So according to Bruner, a concept is a category. Okay, a concept is a category. Therefore, conceptualization means categorization. You form category, right? So look at the definition. A category is the representation of objects or events that have similar properties, right? So of course here, well, when you categorize things, you put all of those that have the same properties or color or whatever into one category, those that are different into another category, right? Now, Bruner describes 5 achievements of categorization, right? First, categorization reduces the complexity of the environment. Right? For example, that is to say, different types of things can be subsumed under a single heading or category. For example, a large group of people, you call it crowd. Is that right? So that what crowd simplifies the situation, right? Simplifies what? You don't have to say a large group of people. You say crowd. All right. It permits, the categorization permits the recognition of objects. For example, if an object does not fit in any way into a category, then it cannot be identified. Is that right? Then for those that can be identified, those can be categorized. Right? And categorization reduces the necessity for constant learning. For example, every time you see an object as simple as chalk, you don't have to learn all over again that that object is a chalk, it is white, it is light, and it is not very palatable. You don't eat it, right? Some professors, they chew on what chalk. Okay? And of course, a chalk can be used to trace lines on a chalkboard, right? So So it reduces the necessity for constant learning. For example, edibles. When you say something was edible, you know that toys, they belong to a category, right? That type of thing. Okay. So it is what reduces the necessity for constant learning. Categorization provides direction for activity. Okay. For example, a naked man holding a sharp butcher's knife chasing a woman. And at once you realize that the guy is not doing that to raise funds for cancer research. Is that right? So you categorize that, okay? So it provides what direction for activity. You stop the guy or you better call the police, right? Number 5, it permits individuals to relate objects and classes of event. So these again serve to reduce the complexity of the environment. Right? So just to simplify our environment. Okay. Look at what Bruner's concept of the coding system. Okay. So it is just a hierarchical arrangement of one concept of increasing or decreasing generality. Okay. All right. So let's take a look at what Bruner's concept of the coding system. Coding systems are related to discovery learning. We will spend time on this later on, okay? So, for example, to fit a new object or concept into an existing coding system, okay? Now, not all categories are at the same level of generality. Is that right? So you have what? Let's say what you have here. We have one generic categories, and then what we have specific categories, and then more specific, another specific categories. Then here something even more specific, more. All right, same. All right, so that's the generic or more general. General, like what? A rule is more general. These are what specific rules, even more specific rules. Right? That type of thing. So that's called a coding system. Okay. So coding systems are related to discovery learning. Okay. So to fit a new object or concept into an existing coding system. Okay, I'll show you how to do that. Okay. Coding systems are related to transfer, that is to say, applying previously learned responses in new situation. Okay, now placing a new object in a coding system facilitates transfer in that it allows the new object to be related to others. And it also suggests what responses to it. All right, so let's take a look at Bruner's coding system. Let's take a look here. These are what? Here we have what? Consumables. We have solids, okay? We have one liquid, but then one liquid is way over here, solid. We have meat, vegetable, fruit, okay? And for meat, we have beef, turkey, okay? Not this here. This is not very good, this one here. Anyway, we have coffee from Colombia, Brazil, tea from India, apple, red, green, and so on. But then let me give you one, a better one. Okay. A coding system for triangles. All right. So this is plain, simple, closed figure. So this is one. Quadrilateral, triangle, another. So look at what coding system for triangle. Isosceles triangle. That is, the three sides are equal. Each one is 60 degrees. Okay. This is scale line. Then you have what? This is right angle triangle, equilateral. Okay, equilateral, equal, yeah, all sides equal, and then other. Okay, let's take a look at what and what. Take a look at Bruner's discovery learning. So what is it? Okay, discovery learning. So Bruner's cognitive theory describes learning and perception as information what? Processing. Describe learning as information processing activities that reflect our need to simplify and make sense of the environment. All right, make sense of the environment. So these activities involve the formation of categories or concepts. Remember, concept is just like category that result from the abstraction of commonalities among events and experience. So things that you put into one category, they share commonalities. Okay. Now, from these abstractions, we derive implicit rules that allows us to categorize or conceptualize the world and discover a world of relationships among concepts. All right. So take a look at one. Discovery learning. So Bruner strongly advocates the use of discovery learning in school. So now, so here, category, concept, what? Here we have specifics about what? Say, for example, examples of the category, right? For example, triangle, we have isosceles triangle, we have equilateral triangle, and so on, right? So discovery learning can be defined as what? As the learning that takes place when students are not presented with subject matter in its final form, but rather are required to organize it themselves. All right? So that is to say, discovery learning equal to inductive learning. So what is it? So that is what? From example to rule, move from specific examples to the formulation of a general principle. Right? Now, what is this? Anyway, let me show you this. Okay, say here, you have a generic categories, or you can say, well, these are rules. All right, then you have one what? type of specific rule and another type of specific rules, or specific rule. Then these are more specific one rules or rule under the specific rule. Okay, for example, here honesty. Here, okay, specific rule: no cheating. Okay, no stealing. Right? And this is what, say, in the school, okay, during the exam or that type of thing, right? That type of thing. So inductive learning is this here, okay, or discovery learning is that learn all these, well, learn, how should I put it? Say, learn all the specific information and then try to induce the rules here at the upper level, then what, induce the general rule, right? So that means what, it is from specific, is it from specific to the general, okay? Or you move from one examples to rule. Okay? For example, here you have one, a rule. And one, you have one, example 1 of the rule, example 2 of the rule, example 3 of the rule. Okay, then inductive learning. Deductive learning is that learn the rule, then understand those what, those examples or those sub rules, for example. But inductive learning is from what? From the examples to the rule. That is, you learn all these what examples and what try to what come up with the rule. So the direction is what? From example to rule, or you move from what specific examples to the formulation of a general one, of a general principle. So one can see that discovery is really the formation of categories, or more often the formation of coding system. Okay, let's take a look at what the characteristics of a discovery approach. Okay, now after the carefully structured initial stages, it requires far less teacher involvement and direction than most other methods. Right? Than most other methods. So because well, students are required to discover. Let's take a look at conditions that facilitate discovery learning. Set. What is set? Okay. Remember in track and field, okay, get set, go, set. The predisposition of individuals to react in a certain way. Okay, so set can orient students to prepare for discovery learning by teaching them to look for relationships among items of information, right? So that is set. Need state, the level of arousal or excitation or alertness of what the learner. So this has to do with what level of arousal. Okay. Now Bruner contends that a moderate level of arousal is more conducive to learning than a too high or too low level. Okay, so that one, this is what we mentioned, that one, Berline mentioned that one, the optimal level of arousal. Okay, not too much, not too low. Right? So that is called the need state of ourselves. Degree of mastery of specifics, that is the extent of the learner's knowledge of specific relevant information. Right? Now, Bruner argues that discovery is not an accidental event, it's not trial and error, quite unlike a Thorndike or Skinner's theory. It is more likely to occur when the individual is well prepared. So how well prepared, that is one. Know more about the specifics. All right. So diversity of training. The wider the range of information the learners process, the more likely they are to find relationships within that information and more likely to develop codes to organize that information. So that is to say, what the learner brings to the situation is essential, right? It's just like what? Prerequisite knowledge, all right? Prerequisite knowledge. All right, let's take a look at what Bruner's theory of instruction. All right, let's take a look at this. I think it is good. Okay, now, so discovery learning means what? Formation of categories or formation of the coding system, right? So Bruner insists that the final goal of teaching is to promote the general understanding of the structure of a subject matter. All right? So Bruner's theory of instruction has four major principles. Okay, motivation, structure, sequence, and reinforcement. Okay, let's take a look at what? Take a look at motivation. Okay, motivation specifies the conditions that predispose an individual to learn. Okay, he believes that what all children have a built-in will to learn. Okay, all of them, okay, sustained by what? Intrinsic motivation. All right? An example will be what? Say, basic intrinsic motivation drive. Okay, that is what, like curiosity, the drive to what? The drive to achieve competence. Okay, and also what? Reciprocity. Reciprocity means what? Cooperation with others. Okay, society evolves based on reciprocity. Remember this. Okay. All right. Here, to nurture these basic drives, teachers must facilitate and regulate the students' what? Exploration of alternatives. Okay, must what? Do this here, exploration of alternative. Now, before we do that, let's take a look at this here, okay? Curiosity is biologically relevant and is necessary for the survival of the species, okay? And naturally, children become what? Interested in what they are good at. So what? That competent drive. So reciprocity involves the need to work with others cooperatively. And Bruner feels that was society itself developed as a result of this most basic one, motivation. All right, so to nurture all this here, well, Bruner suggests that teachers must facilitate and regulate their students' exploration of alternatives. So exploration of alternatives has three phases: activation phase, maintenance, and direction. Activation is to activate the exploration. The children must experience a certain level of uncertainty, a slight discrepancy in their knowledge. All right, that's William James' notion and Hunt's notion of mismatching. Okay, William James start where the learner is, then David Hunt is what? It's a matching and mismatching gradually, okay, mismatching. Okay, so that is what a good way to what activate. Maintenance, to ensure the children that exploration is not going to be a dangerous or a painful experience, but rewarding. So that is to say, advantages are far more than the risk. All right. Lastly, direction. Exploration of the alternative. The exploration is guided. So the direction of exploration is a function of two factors. Okay. The first one, knowledge of the goal. Second one, knowledge that the exploration of alternatives is relevant to the achievement of that goal. Okay. How close they are to achieving the goal. Right? So knowledge of the goal is it is important, is that right? So you know about what you know about what you're going to get. So Bruner's second principle, structure. Any body of knowledge can be organized in some optimal fashion so that it can be transmitted to and understood by almost any student. Okay. The structure of any body of knowledge can be characterized in three ways. Okay. One, the mode of presentation. Okay. And one, economy of presentation, power of presentation. Let's take a look at mode of presentation. Let's take a look at mode of presentation. The technique, the method whereby information is communicated. So the teacher's mode of presentation should fit the child's level of experience. Start where the learner is, right? So there are three means of achieving understanding. An active representation, to understand in terms of actions. In terms of actions, it's what like Piaget's sensory motor stage, and sometimes what you have to do it in order to understand it. Right? So to understand in terms of action, in judo class, you will have to do it to understand it. Okay, iconic representation. Iconic representation. Objects become more conceivable without action. So that iconic representation. Here, the child moves from sensory motor to pre-operational, or at least pre-operational. Okay, all right. Symbolic representation. Okay, look at symbolic representation. When experience can be translated in language, right? So that is symbolic representation, right? So that is what? That is more advanced than iconic representation. Now, say an example of iconic representation, the children can draw a picture of an apple without what? Acting out the eating process, is that right? But then symbolic representation, it requires what? Mastery of language, is that right? So without language, we can't do that, right? Economy of presentation. The fewer bits of information, the fewer facts the learner must bear in mind in order to continue learning, the greater the economy. Okay, so economy of presentation, for example, a concise summary, right? So remember that what in most journal papers at the beginning is the abstract, is that right? The abstract what informs you about what you're going to read, is that right? The abstract normally not more than 150 words, okay? Power of presentation. A power presentation is a simple presentation, one that is easily understood. Now, some teachers often make it difficult what is inherently easy. But anyway, power presentation is not that easy, is that right? So one, a simple presentation, no matter how complicated the subject matter is, if we could present it in a simple way, that so that people can understand that is beautiful, and that is very difficult to do, okay, to have power of presentation. Sequence, the Bruner's third principle, sequence. The sequence in which the material is presented. Well, since intellectual development is innately sequential, Bruner believed that moving from what? An active phase to iconic to symbolic is the best sequence for any subject to take. See, it requires action. Here, it requires what? Requires representation, iconic represent, and symbolic is more advanced than this, more advanced than this. All right. So the last one, the fourth principle, reinforcement. Reinforcement. Okay. Very much one, say Skinner's idea. Learning requires reinforcement. Okay. Students require what? Feedback, as to know how they are doing. So that one, that is also reinforcement. Now, say essay assignment, okay? It is a good idea for markers to put down comments on the paper, on the long essay paper, okay? Say, oh, this is good, okay, or this is not right, okay, because of this. Most students like comments on their essay paper, so that they have an idea why they score so low or why they score so high, right? So take a look at let us do a conclusion, okay? P-learning is primitive. We go from P-learning to LM learning as we continue to develop LM learning. So as we continue to grow, continue to develop. LM learning represents a more advanced or higher level stage of cognitive operation. Most behavior modification techniques depend on P-learning, okay, P-learning concept, because they are more basic, Okay, but then LM learning is more is far more advanced. Okay, and as we come to IQ, okay, discussing IQ, we know that here IQ is basically a result of LM learning. Okay, and you know that basically IQ tests, almost all IQ tests are testing logical, mathematical, and plus linguistic knowledge. Right? So that I can test, and we'll come to I can test. Okay. All right, good. So that's Bruner's theory. Okay. Categorization, conceptualization. All right. Thank you.